The drilling part of mineral exploration is really the first time that you can get your hands on the rock that is under your feet.
There's lots of ways to actually target drill holes. You can do it from geophysical data, that could be magnetic field information, gravity field information. You can do it from straight geology, from the geological map that you have available to you, or rocks you've seen in the field. You can do it from geochemical information, where you go out and take soil samples, for example, and you might target drill holes where there's elevated values of gold, for argument's sake, or copper or nickel, whatever you happen to be looking for. So a combination of all those techniques is typically how you would target a drill program.
Having the confidence of where to drill really comes back to the exploration geologist and often the experience of that geological team. They have to make a decision on the type of drilling, also the depth that the drilling should continue to, and it comes from that whole picture that has evolved from the understanding of the regional geology, the results from the geophysics, and the results from the geochemistry.
The typical types of drilling, there are usually sort of three, I would say. The shallow ones being what they call air core or RAB, that's rotary air blast drilling.
The problem is the samples are actually blasted up at the outside of the actual drill tubes themselves, so you tend to have a lot more contamination associated with that type of drilling.
The mid-depths would be typically RC, that stands for reverse circulation drilling.
And it is a percussion method again, so it's pounding away at the rocks, producing drill chips.
And then deeper drilling is done by what we call diamond drilling.
The sample that you produce is a continuous piece of drill core, which provides fantastic information for geologists, geochemists and geotechnicians.
The difference between the three is partly in cost, partly in penetration depth, as I've referred to, and then probably most importantly in the quality of the actual geological sample that you actually get back from the type of drilling that you undertake.
At each stage you will be doing analysis, geological observation of the materials that you're recovering, a chemical analysis for the metals that you are hopefully looking for, and you can now start, of course, to observe the minerals in their host location, understand the size of mineral grains, the association, and what this actually means should you progress into a mining and a processing operation.
We've not yet evolved in terms of our technical skill set to the level where we can drill a hole and hit every time. The hit rates vary based on different commodities. If you're out in the middle of nowhere drilling for a new metals discovery, it's sad to say your potential hit rate of new discovery will be well less than 1%.
Drilling, well, it's an art and a science, is a very important profession to the mining industry, and it has associated safety risks, not just from that of the moving machinery that is involved, but also in an Australian context, the risk of snake bites, dehydration, sunburn. It's all built into a risk assessment and the training of the drillers.
I'd say in the drilling space really two aspects of health and safety risk. One, that people are working in quite often in quite remote areas, such that any injury that is sustained, you're a long way from the local hospital, so one needs to have plans in place to actually evacuate people to somewhere where they can receive proper treatment.
The results from drilling programs are of paramount importance to exploration companies because they really are an indicator of success or failure. And of course, no one really wants to put money into failure, but everyone is quite willing to put money into success.
It goes back to the 1930s and the hotelling principle. And basically it boils down to the value of any mining company is the amount of ore, oil reserves they have, less the cost of extracting it.